somewhere in the southern North Sea. On an ordinary morning in 1931, a Dutch fishing trawler dragged its net across the seafloor and pulled up something that did not belong to any living creature. A jawbone, human, preserved in a way that salt water alone does not explain. The fisherman who held it did not know how old it was. He did not know that the seafloor beneath his boat had once been dry land. He did not know that the person this bone had belonged to had lived and died in a world that no map has ever shown, in a landscape that existed before the sea arrived and decided to stay. He set it aside. He had fish to sort. That jawbone is still one of the most consequential objects ever pulled from the North Sea. Not because of what it is, because of what it points toward. Beneath the grey water stretching between England and continental Europe, under the shipping lanes and the gas pipelines and the slow, indifferent pull of tides, there is a landscape, rivers that ran for hundreds of kilometers before the sea swallowed them, lakes that held still water under open sky, the places where people built fires and raised children and buried their dead in ground that is now 30 meters underwater. We cannot know their names or their specific stories. The evidence does not reach that far, but it allows us to imagine someone like this, a woman kneeling at the edge of one of those rivers, in the grey light before the rest of her camp woke, checking a fish trap she had set the evening before. The river around her was wide and slow, and the morning fog sat close to the water. She did not know she was living in a world the sea would eventually take. She only knew the river, the trap, the weight of what she hoped to find in it. We are only now learning how to read the world she lived in. Welcome to Forgotten Earth. This is the story of Doggerland. Welcome to Forgotten Earth. Chapter 1. The Land That Had No Name. To understand what was lost, you first have to understand what was there. That requires a deliberate act of imagination, because every physical feature of that world is now hidden under an average of 20 to 40 meters of seawater. There are no ruins visible from the surface. There is no shoreline you can walk and feel the shape of. The landscape exists now only in the data pulled from sonar surveys and sediment cores, and the occasional object dragged up by a trawl net that was meant to catch something else entirely. But the landscape was real. It was not marginal or inhospitable or a geographic afterthought. By every measure available to the researchers who have spent the last 3 decades reconstructing it, Doggerland was one of the most productive and ecologically generous environments in all of post-glacial Europe. Understanding why requires going back further than Doggerland itself, back to the world that existed before the ice retreated and made Doggerland possible. At the peak of the last glacial maximum, approximately 26,000 years ago, the planet looked fundamentally different from any map a modern person has ever consulted. Ice sheets covered much of the northern hemisphere, extending south across what is now Scandinavia, across the British Isles, and deep into the European continent. Sea levels were dramatically lower than they are today, because an enormous volume of the world's water was locked into those ice sheets rather than circulating through the oceans. The best current estimates place sea level at the glacial maximum, somewhere between 100 and 120 meters below its present position. That difference is not a small adjustment. It is a transformation of continental geography. The area now occupied by the southern North Sea was not underwater. It was a vast, flat, low-lying plain connecting what is now Britain to what is now Denmark, Germany, the Netherlands, and Belgium, without any intervening water at all. Britain was not an island. It was a peninsula, attached to the European mainland along a broad corridor of land that extended further north and east than most people have any intuitive sense of when they look at a modern map. This exposed landmass was not hospitable during the glacial maximum itself. The climate was cold, dry, and dominated in many areas by tundra vegetation, supporting the large cold-adapted animals of the Pleistocene. Woolly mammoth, woolly rhinoceros, cave lion, and giant deer moved through landscapes more similar to the modern Siberian steppe than anything existing in northwestern Europe today. Human populations during the coldest phases were sparse and concentrated toward the southern refugia of France, the Iberian Peninsula, and Italy, where conditions remained survivable. But the glacial maximum did not last. The cycle of glacial and interglacial periods turned again, as it had many times before, beginning around 19,000 years ago, and continuing across the following 10,000 years. The ice retreated, not smoothly or continuously. The deglaciation was punctuated by reversals and pauses, and in some cases abrupt accelerations. But the overall direction was consistent. The ice pulled back northward. Meltwater filled the ocean basins. Ecosystems compressed into southern refugia, expanded northward into newly opened land, and into that expanding world. The low-lying plain that would eventually become the North Sea began its long transformation. During the early phases of deglaciation, roughly between 18,000 and 10,000 years ago, the exposed plain was changing from tundra into something considerably more complex and generous. As temperatures rose and precipitation patterns shifted, the landscape was colonized first by birch and pine woodland, then by the richer mixed forests of oak, elm, and hazel that characterized the Atlantic period of European prehistory. Rivers draining off the retreating ice sheets carved channels across the plain. Lakes formed in topographic depressions. Wetlands developed along river margins and in low areas where drainage was impeded. The river system of this landscape is one of its most striking features, and one of the aspects that modern research has documented with the greatest confidence. Vince Gaffney, of the University of Bradford, whose team produced the first systematic mapping of the submerged Doggerland landscape beginning in the early 2000s, identified a major river system draining the interior of the plain northward toward what was then the open ocean. This paleo river was fed by tributaries that included the ancestral Thames flowing from the west and the ancestral Rhine flowing from the southeast. What is now a coastline dotted with separate river mouths was once a single unified drainage system, emptying through a common outlet far to the north of any present land. The ecological consequence of this geography was significant. A large river system draining a broad catchment creates a ribbon of continuously productive habitat running through the landscape. River margins support dense vegetation. Oxbow lakes and seasonal floodplains are rich in waterfowl and fish. The interface between riverine wetland and drier upland is precisely the kind of edge habitat that concentrates wildlife, and that human hunters and gatherers throughout prehistory have consistently sought out and exploited with particular intensity. Dogger Bank is the most prominent topographic feature of this vanished landscape. Today it is a shallow submarine bank in the central North Sea, rising to within 15 to 30 meters of the surface, and well known to generations of North Sea fishermen as one of the most productive fishing grounds in European waters. Its productivity as a fishing ground is itself a kind of legacy. The shallow water over Dogger Bank sits above what was once higher ground in the Doggerland landscape, a broad, elevated area that would remain above the encroaching sea long after the surrounding lower areas had been inundated. The name Doggerland itself was coined by the British archaeologist Brian E. Coles in 1998, in a paper that was among the first to synthesize the available evidence into a coherent picture of the submerged landscape and argue for its significance as a cultural and ecological zone. Before Coles gave it that name, the concept existed in scattered references in the geological and archaeological literature, but without a single term that made it easy to discuss as a unified entity. The name came from the Dogger Bank, which itself takes its name from the Dutch word for a type of fishing vessel historically used in those waters, a landscape named after a boat. There is something fitting in that. The sea had the last word, and the fishermen, without knowing it, preserved the first. What Coles was arguing in 1998, drawing on work that geologists and marine archaeologists had been piecing together across the preceding decades, was that Doggerland was not simply a geographic curiosity or an interesting footnote to the story of post-glacial Europe. It was a central feature of that story. During the period when it existed at its maximum extent, roughly between 12,000 and 8,000 years ago, Doggerland would have been home to a significant proportion of the human population of northwestern Europe. Its rivers, wetlands, coastal margins, and interior uplands would have provided the full range of resources that Mesolithic communities required, and in many seasons would have provided them more reliably and more abundantly than the higher ground to the east and west that remained above sea level. Understanding Doggerland is not understanding a peripheral story. It is understanding the center, the heart of a world that produced people whose descendants eventually built Stonehenge, the megalithic monuments of Brittany, and the first farming settlements of the European plain. That world is gone. It is under the water now, pressed into the sediment, mostly inaccessible, mostly silent, but not entirely silent, because the sea preserved things as well as destroyed them. The cold, oxygen-poor mud of the North Sea floor is in many places an extraordinary archive. Organic materials that would have decayed entirely in any terrestrial context have survived in that mud for thousands of years. Bone, wood, in some cases the preserved remnants of plants that grew on the margins of rivers that stopped flowing before any living person's earliest ancestor drew breath. The fishermen pulling up jawbones and harpoon points in their trawl nets were not finding debris. They were finding pages of a book that no one had known how to read until very recently. And the reading has only just begun. Chapter 2. The First People. There is a temptation, when thinking about people who lived 8,000 or 10,000 years ago, to imagine them as simpler versions of ourselves. Fewer tools, less knowledge, a narrower world, bounded by whatever they could see from the highest hill within a day's walk. That temptation should be set aside entirely. The people who lived in Doggerland during the Mesolithic period, roughly between 12,000 and 6,000 years ago, were anatomically and cognitively identical to any person alive today. The same brain architecture, the same capacity for language, for planning, for the accumulation and transmission of complex knowledge across generations. What they lacked was not intelligence or social sophistication. What they lacked was writing, and the particular kind of institutional memory that writing makes possible. Everything else, the capacity to observe, to reason, to build intricate social relationships, to develop specialized expertise across a lifetime and pass it carefully to the next generation. All of that was fully present. This distinction matters enormously for how we understand what Doggerland actually was. It was not a primitive landscape occupied by primitive people. It was a sophisticated human world, organized around a detailed and accumulated understanding of a specific environment, maintained by communities whose practical knowledge of their landscape was in many respects more precise and more intimately held than most modern people's knowledge of any landscape they have ever inhabited. Think of someone like the woman imagined in the opening of this story. She was not guessing about the fish trap. She knew where to place it because someone had shown her, and that person had been shown by someone before them. And across those generations of showing and learning, the specific knowledge of that specific river had become something as reliable as instinct. She knew which bend to choose and why. She knew what the fog on the water in the morning meant for the fishing that day. That kind of knowledge was not written anywhere. It lived in the body and the memory and the repeated daily encounter with a specific place across a specific life. The Mesolithic period in northwestern Europe is the archaeological designation for the phase between the end of the last glaciation and the arrival of farming from the southeast. The name means middle, reflecting the original classification of this period as transitional. That framing has been progressively revised as evidence accumulated. The communities of the European Mesolithic were not simply waiting for agriculture to arrive. They had developed ways of living that were, in many environments, extraordinarily successful on their own terms. In the landscape of Doggerland, Mesolithic communities would have organized their lives around a seasonal round, not a fixed settlement in the modern sense, but a structured pattern of movement through the landscape that returned reliably to productive locations at the times of year when those locations offered their greatest returns. River confluences in spring, when migrating fish ran upstream and waterfowl gathered in wetlands. Woodland interiors in autumn, when hazelnuts and other mast crops were available in abundance. Coastal margins and estuaries in late summer, when shellfish beds were accessible and marine mammals hauled out on beaches. The evidence for this kind of structured mobility comes not from Doggerland itself, where the preservation of in situ archaeological sites remains extremely difficult, but from contemporaneous sites on the higher ground surrounding what was once the Doggerland landscape. Sites in Britain, the Netherlands, Denmark, and Germany from this period show communities with sophisticated tool technologies, diverse subsistence strategies, and strong evidence of repeated return to favored locations over many generations. The stone tool technology of these communities, characterized by small, precisely shaped flint tools called microliths, was designed for versatility and portability. Microliths were hafted into composite tools, arrows, spears, knives, and other implements, in combinations that could be assembled and modified as different tasks required. The knapping skill required to produce consistent microliths was a craft learned over years, maintained through practice, and passed from experienced knappers to the next generation through direct instruction and observation. The quality of tools found at Mesolithic sites across northwestern Europe reflects communities in which specialized knowledge was cultivated deliberately. Beyond stone tools, these communities worked extensively in organic materials that rarely survive in archaeological contexts. Bone, antler, and wood were shaped into tools and objects whose sophistication we can only partially reconstruct from surviving examples. It is here that the North Sea bottom has been particularly generous, because the conditions that destroyed everything on land preserved extraordinary things in the seafloor sediment. The harpoon points recovered from the North Sea floor over the past century are among the most significant objects in the entire story of Doggerland. Made from bone and antler, barbed along one edge in a design refined across generations of practical testing. These points are not rough or experimental objects. They are the products of a mature and sophisticated craft tradition. The barbing is precise. The base is shaped for reliable hafting. These are tools made by people who knew exactly what they needed and exactly how to make it. One particular find deserves specific attention. A barbed antler point recovered from the Brown Bank area, a submarine ridge in the southern North Sea between the present Dutch and English coasts, was found in association with a fragment of peat that allowed radiocarbon dating to approximately 11,500 years ago. That combination, organic context and associated artifact, is what transforms an isolated find into a more interpretable piece of the archaeological record. The date places human activity in this area within a few centuries of the end of the Younger Dryas Cold period, in the very earliest warmth of the Holocene. The people using that harpoon were among the first generation to inhabit a landscape that had only recently become livable by the standards of a new, warmer world. The diet of Mesolithic communities in and around Doggerland was diverse in ways that reflected the ecological richness of the landscape. Stable isotope analysis of human remains from contemporaneous sites in Britain and Scandinavia indicates significant consumption of both terrestrial and aquatic resources. Red deer, wild boar, aurochs, and beaver were hunted on land. Fish, including pike, perche, and various marine species, were caught in rivers, lakes, and coastal waters. Shellfish were harvested from estuaries and rocky shores. Wild plant foods, hazelnuts, water lily seeds, various roots and berries, contributed to the diet in ways the plant remains from waterlogged sites confirm. This dietary diversity was not simply opportunistic. It was a strategy. Communities that could draw on multiple resource types were buffered against the failure of any single resource in a bad year. A poor run of migratory fish could be compensated by a good hazel harvest. A summer drought that reduced plant productivity could be offset by increased reliance on hunting or shellfish. The ecological knowledge required to maintain this kind of flexible, multi-resource strategy was accumulated over generations and constituted one of the most valuable assets any Mesolithic community possessed. Social life in these communities was more complex than the older models suggested. Evidence from burial sites across northwestern Europe, particularly from the cemeteries at Skatholm in southern Sweden and Vedbæk in Denmark, which date to roughly the same period as the later phases of Doggerland occupation, shows communities investing in elaborate mortuary practices. Bodies were buried with personal ornaments made from animal teeth, shells, and amber. Some burials contain objects suggesting differential social roles within the community. The care taken in burial points to communities with well-developed beliefs about the relationship between the living and the dead. None of these burial sites are within Doggerland itself. They are on the higher ground that remained above the rising sea. But they represent the same broad cultural tradition, the same social world that was also being expressed across the now submerged landscape. The people buried at Skatholm and Vedbæk were not from a different culture than the people fishing the rivers of Doggerland. They were neighbors, relatives, trading partners, participants in the same broad social network that connected communities across northwestern Europe during the Mesolithic. That social network is itself one of the most important and least appreciated aspects of this world. The exchange of flint raw materials, amber, and other goods across distances of hundreds of kilometers, documented at Mesolithic sites across Europe, implies regular contact between communities separated by significant geographic distance. People were moving, meeting, exchanging, intermarrying, and sharing information across a landscape that most modern people would find challenging to traverse without mechanical transport. Doggerland, positioned at the center of this network, was not simply a place where people lived. It was a place where people from multiple surrounding regions converged. Its rivers and estuaries and seasonal gathering places would have been meeting grounds, locations where communities whose daily lives were spent in separate territories came together at predictable times of year, exchanged goods and people and knowledge, and maintained the broader social fabric that individual communities could not sustain in isolation. When that center disappeared under the rising sea, it was not only a landscape that was lost, it was the organizing geography of a social world. The consequences of that loss extended far beyond the people who had lived there directly. Chapter 3. Ice, Water, and the Slow Catastrophe. The word catastrophe implies speed. A catastrophe, in ordinary usage, is something that happens fast. A fire, a flood, a collapse, something that crosses the threshold from normal to disaster within a time frame that human perception can register as sudden. The drowning of Doggerland was not a catastrophe in that sense, and that is precisely what makes it so difficult to grasp, and in some ways so much more unsettling than a sudden disaster would have been. It was a slow catastrophe, a process that unfolded across thousands of years, driven by forces operating at a planetary scale, entirely indifferent to the communities living in its path. The sea rose, not all at once, not even visibly, from one season to the next. For much of the process, it rose the way a tide rises when you are not watching closely. A meter here, a few meters there, a shoreline that had been familiar for a generation becoming, over the course of several generations, something you had to walk further to reach. Understanding the mechanism requires understanding why the sea was rising at all. During the last glacial maximum, the enormous volume of water locked in the great ice sheets of North America, Eurasia, and Antarctica represented water that had been removed from the global ocean system. The ocean basins were holding less water than they hold today, and sea level was correspondingly lower. The figure most commonly cited in the scientific literature is approximately 100 to 120 meters below present sea level, though the precise estimate varies depending on the methods used and the period being measured. As the climate warmed and the ice sheets melted, that water returned to the oceans. The process is called glacio-eustatic sea level rise, and it is one of the most significant geographic transformations that has occurred on this planet within the time frame of human existence. The total area of land that was exposed during the glacial maximum and subsequently submerged by post-glacial sea level rise is enormous. Estimates suggest that somewhere between 5 and 10 million square kilometers of land globally have been inundated since the glacial maximum. Doggerland was one portion of that global inundation. The rate of sea level rise was not constant across this process. It varied considerably depending on the pace of ice sheet melting, which itself responded to changes in solar insolation, ocean circulation, and the complex feedbacks within the climate system. Periods of rapid ice sheet collapse produced pulses of accelerated sea level rise. The most dramatic of these, documented in the sea level record as Meltwater Pulse 1A, occurred approximately 14,600 years ago and may have raised global sea levels by somewhere between 14 and 18 meters within a period of a few centuries. That is a rate of rise orders of magnitude faster than anything observed in the modern instrumental record. For the communities living in low-lying coastal areas during such a pulse, the experience would have been genuinely alarming. A shoreline that had been stable within living memory receding year by year, coastal landmarks disappearing within a generation. The mental map of a landscape, learned over a lifetime and refined across generations, becoming unreliable in ways that had no precedent in accumulated experience. But between these pulses, the rise was slower. During the period most directly relevant to Doggerland, roughly between 10,000 and 8,000 years ago, sea level in the North Sea region was rising at rates that various estimates place at somewhere between 1 and 2 meters per century on average, with considerable variation depending on location and time period. 1 to 2 meters per century is roughly 10 to 20 millimeters per year. That is slow enough that in any given season, the change would have been essentially imperceptible to an individual observer. A person living their entire life in one place on the Doggerland coast might not have noticed the sea getting meaningfully closer over the course of their lifetime. But across 5 generations, across 10, the change would have been undeniable. The specific geography of the Doggerland inundation is something researchers have worked to reconstruct in considerable detail. The southern North Sea basin is not flat. It has topographic variation, areas of higher ground and lower ground, river valleys and coastal plains and internal basins. As sea level rose, the inundation did not proceed uniformly across the whole landscape at once. It moved along channels, pooled in basins, advanced rapidly across flat lowlands, and paused where higher ground slowed its progress. Vince Gaffney and colleagues at the University of Bradford, working with seismic survey data originally collected by the oil and gas industry and repurposed for archaeological and geological analysis, produced a series of maps showing the progressive inundation of the Doggerland landscape at different points in time. These maps, published as part of the Europe's Lost Frontiers project, funded by the European Research Council, represent the most detailed reconstruction of the Doggerland landscape currently available. They show a landscape that at its maximum extent, around 10,000 years ago, was comparable in area to the modern United Kingdom, containing within it a diversity of environments ranging from inland forests to coastal marshes to estuarine systems that would have been among the most productive natural environments in post-glacial Europe. By 9,000 years ago, according to these reconstructions, the picture had changed significantly. The lower-lying areas to the south and east had been inundated. What had been a continuous land bridge connecting Britain to the continent had been reduced to a narrowing corridor. The broad river valleys of the interior were becoming estuaries as the sea pushed into them. By 8,000 years ago, Britain was becoming an island. Not suddenly, not on a specific day that anyone could have identified as the moment of separation. But the corridor of land that had connected it to the European continent was being reduced to a tidal flat, then to a strait, then to the open sea that exists now. The English Channel, the stretch of water that would one day define British history and British identity for all of recorded time, was being born. There is one further dimension of the sea level rise story that deserves careful attention, because it complicates the picture of a uniformly gradual process. The weight of the ice sheets that covered northern Britain and Scandinavia during the glacial maximum had depressed the land beneath them. As the ice melted, the land began to slowly rebound upward in a process called isostatic rebound. This process is still occurring in Scandinavia today, where land is rising at rates of up to 8 millimeters per year in some areas. The consequence for the North Sea region is that the relative sea level change experienced by communities in different parts of the Doggerland landscape was not the same everywhere. The southern North Sea was in the subsiding rather than rebounding zone, which means the communities there experienced sea level rise at rates higher than the global average. The lower-lying portions of Doggerland were disappearing faster than the global sea level curve alone would suggest. And then, on top of this slow, inexorable process, something sudden happened. Something that did not give anyone time to adjust, or plan, or carry what mattered to higher ground. Something that arrived, as truly sudden things do, without warning. Chapter 4. Doggerbank. The last island. There is a particular kind of loneliness that belongs to the last of something. Not the loneliness of isolation, which is simply a condition of geography, but the loneliness of reduction, of knowing, in whatever way knowledge registers without written language or historical perspective, that the world you are standing in is smaller than the world your grandparents described, that the places they named, the rivers they followed, the gathering grounds they returned to each season, are no longer reachable, that the water has taken them and is not giving them back. The people living on Doggerbank in the final centuries of its existence above sea level would not have had a name for what was happening to them. They had no geological framework, no concept of ice ages or interglacials, no way to understand that the sea rising around them was connected to the melting of ice sheets thousands of kilometers to the north. What they had was observation, memory, the accumulated testimony of generations who had watched the same process from the same shrinking ground. Doggerbank today is a submarine shoal in the central North Sea, roughly 300 kilometers east of the English coast, and about the same distance west of the Danish and German coastlines. It is large, covering an area of approximately 17,000 square kilometers, and shallow, with water depths ranging from 15 to 30 meters over most of its extent. Those shallow depths are what make it one of the most productive fishing grounds in the North Sea. The sunlight penetrates to the bottom, nutrients accumulate, fish concentrate in the shallow warm water above the bank in numbers that have sustained North Sea fishing fleets for centuries. Those shallow depths are also what made Doggerbank the last portion of the Doggerland landscape to disappear beneath the waves. The reconstructions produced by Gaffney and colleagues suggest that by approximately 9,000 years ago, Doggerbank had become an island. The surrounding lower ground had been flooded. The connections to the British landmass to the west and to the European continent to the east had been severed or reduced to tidal channels. What had been a broad inland upland within a larger landscape was now a substantial island sitting in the expanding North Sea. That island was not small. The exposed area of Doggerbank, at the point when it first became surrounded by water, was, by various estimates, somewhere in the range of several thousand square kilometers. large enough to contain a diversity of habitats, to support populations of terrestrial game, to offer fresh water from rivers and lakes fed by rainfall, and to provide coastal access to the marine resources of the surrounding shallow sea. Whether Dogger Bank was inhabited during this island phase is a question the available evidence cannot yet answer with certainty. The balance of evidence suggests that occupation was likely, but that conclusion should be held with appropriate humility about what the current archaeological record can and cannot confirm. The artifact record from the North Sea bottom in the area of Dogger Bank is not rich, but it is not empty. Bone and antler tools, animal remains, and occasional flint artifacts have been recovered from the seafloor in this general area over many decades of accidental trawling. The challenge of interpreting this material is significant. Because the trawling process that recovers, it also disturbs the sediment context that would allow precise localization and dating. But the presence of this material tells us that human activity occurred somewhere in the area during relevant periods. The animal remains recovered from the North Sea bottom in the Dogger Bank area tell us that the fauna of this landscape included a range of species consistent with a productive, temperate environment. Red deer, aurochs, horse, and beaver remains from the Mesolithic period suggest the temperate woodland and wetland fauna that would have characterized the landscape as the climate warmed. These were animals that human hunters pursued. In 2013, a small piece of worked peat, shaped in a way consistent with human modification, was recovered from the seafloor in the southern Dogger Bank area and radiocarbon dated to approximately 7,800 years ago. 7,800 years ago is a date within the window when Dogger Bank was already an island, or very close to becoming one. The interpretation of this material as evidence of late human occupation in the area is plausible and consistent with the broader picture, though the provenance limitations of trawl-recovered material mean it should be treated as suggestive rather than conclusive. Bryony Coles used the phrase the Dogger Hills to describe what is now Dogger Bank as it would have appeared in its island phase. The phrase is simple but effective. It places you there, on higher ground, looking out over water that you know, from the testimony of the generations before you, used to be land. The hills you are standing on were once the interior of a continent. The psychology of that situation is something we can only approach from the outside. Human communities have faced the loss of homeland throughout history, through conquest, through forced migration, through environmental change. The responses documented in the historical and anthropological record share certain features: intensified attachment to the remaining territory, elaboration of the symbolic significance of specific places within that territory, increased investment in the social bonds that define community identity when geographic continuity can no longer be taken for granted. Whether the communities of late Doggerland expressed any of these responses in ways that have left archaeological traces is something the current evidence does not allow us to say. The underwater archaeology of Dogger Bank has barely begun. The logistical challenges of excavating in 30 meters of water in the central North Sea are formidable, and the funding for such work has not matched the scientific interest in what it might reveal. What the balance of evidence suggests is that Dogger Bank was not immediately abandoned the moment it became an island. Communities likely remained, adapting to island life in a landscape still capable of supporting human habitation. They fished the surrounding shallow sea. They hunted whatever terrestrial game remained. They maintained, as best they could, the social connections with communities on the surrounding land masses that survival as a small island population would have required. These were not data points in a sea level curve. They were people who woke up every morning on an island that was smaller than the island their parents had grown up on, who looked at the water from the highest point they could reach and saw, somewhere out there in the direction of memory, the place where the land used to be. Imagine someone like the woman from the opening of this story, or her granddaughter's granddaughter, standing on those hills generations later, looking at the same water, the fish trap still set at the edge of a sea that was still, slowly, getting closer. And then one day, the sea did something different from what it had always done. It did not simply rise. It arrived. Chapter 5. Storegga. The day the sea arrived. There are events in the natural world that operate on timescales humans can comprehend directly. A storm builds over hours. A flood rises over days. Even a volcanic eruption usually announces itself with tremors and smoke before the decisive moment. And then there are events that give no warning at all. That arrive at the speed of water moving faster than a person can run. With no precursor that any accumulated human experience would have taught anyone to recognize. The Storegga slide was that kind of event. On a day approximately 8,200 years ago, a section of the continental shelf off the western coast of Norway failed. Not a small slippage. A catastrophic underwater landslide involving somewhere between 2,500 and 3,500 cubic kilometers of sediment. That volume of displaced sediment displaced an equivalent volume of water. The energy released entered the ocean as a tsunami. Not a single wave, but a series of waves, propagating outward from the slide area across the North Atlantic and the North Sea. The evidence for the Storegga tsunami is preserved in the sedimentary record of coastlines around the North Sea basin, and it is among the most clearly documented geological events of the post-glacial period in northwestern Europe. David Smith of Coventry University and colleagues, along with research groups in Norway and Scotland, documented tsunami deposits at multiple sites along the Scottish, Norwegian, and Shetland coastlines in work published across the 1990s and 2000s. These deposits, layers of marine sand and shell material found inland of the contemporary shoreline and above the normal tidal range, are in some locations several meters thick and extend kilometers inland from the coast. At Montrose Basin on the east coast of Scotland, tsunami sediments have been found significantly inland from the present coast, deposited at elevations above present sea level. At sites along the Norwegian coast, the deposits reach even greater inland extents. The geographic distribution of confirmed tsunami deposits from the Storegga event now includes sites in Scotland, Norway, the Shetland Islands, the Faroe Islands, and Greenland, forming a pattern consistent with the modeled propagation of waves from a source area off the Norwegian coast. The height of the waves when they reached the coastlines surrounding the North Sea is estimated from the elevation and extent of these tsunami deposits. Those estimates vary by location depending on local topography and the specific conditions of each site. In Shetland, run-up heights of more than 20 meters above contemporary sea level have been estimated from the deposit evidence. Along parts of the Scottish east coast, run-up heights of between 5 and 10 meters are indicated. These are site-specific estimates, and the picture likely varied considerably across the broader region. Now, place those numbers in the context of the Doggerland landscape as it existed approximately 8,200 years ago. By that point, Doggerland had already been substantially reduced by ongoing sea level rise. What remained above sea level was concentrated on higher areas, including Dogger Bank and the elevated margins adjacent to what was becoming the English Channel and the approaches to the North Sea. The coastline of this reduced Doggerland was not a high rocky shoreline with cliffs and elevated ground behind it. It was, in many places, a low-lying coastal plain, flat, barely above sea level even under normal conditions. A tsunami wave of 5 to 10 meters, striking a coast that is barely 1 to 2 meters above sea level, does not simply flood the immediate shoreline. It travels inland across flat ground with very little to slow it until it reaches genuinely elevated terrain. Across a flat coastal plain, a wave of that magnitude would penetrate kilometers inland, carrying sediment, destroying vegetation, and then withdrawing back to the sea, carrying whatever had been on that ground with it. Research modeling the Storegga tsunami's effect on the Doggerland landscape suggests the wave energy reaching the low-lying coastal areas could have been sufficient to inundate substantial portions of the remaining above sea level terrain. It is important to note that this modeling work is still being refined. Recent scholarship, including work reassessing the broader regional effects of the Storegga event, has emphasized that impact likely varied significantly depending on local topography, and that some areas may have fared considerably better than others. The picture is one of severe but geographically variable disruption, rather than total uniform destruction. What the Storegga event almost certainly did, even in more conservative assessments of its regional impact, was dramatically compound a situation already under severe stress. The areas of worst impact were precisely the areas where the surviving population of Doggerland had been concentrating as sea level rise compressed their available territory. Low-lying coastal margins that offered the richest access to marine resources were the same margins most exposed to the wave. The water withdraws after a tsunami. The ground that is exposed afterward is still ground. But it is ground that has been profoundly altered, stripped of its vegetation, covered with a layer of marine sediment, contaminated with salt water that would take years of rainfall to leach from the soil before terrestrial plants could re-establish. For communities living on that low-lying coastal terrain, the event would have arrived without warning. There may have been, in the minutes before the wave arrived, a withdrawal of the sea from the shoreline, the characteristic drawback that precedes a tsunami as the trough of the wave arrives before its crest. To people unfamiliar with this phenomenon, that withdrawal might have appeared merely strange, an unusual tide, something to observe rather than to flee from. And then the water came back. It would be inaccurate to describe the Storegga tsunami as the single event that ended Doggerland. The sea level rise already underway would eventually have submerged the remaining terrain regardless. Dogger Bank would have disappeared beneath the North Sea whether or not the Storegga slide had ever occurred. The fundamental driver of Doggerland's disappearance was the post-glacial sea level rise, and that process was not permanently altered by the tsunami. What the Storegga event almost certainly did was change the human timeline of abandonment. Communities still present on Dogger Bank and the adjacent elevated margins, adapting incrementally to a slowly rising sea, may have found their situation transformed suddenly into something that incremental adaptation could no longer address. Settlement areas marginally viable before the wave may have been rendered uninhabitable afterward. The social networks that had allowed island communities to maintain connections with mainland populations may have been severely disrupted. The Storegga event has been connected by some researchers to evidence for disruption in the Mesolithic archaeological record of the regions surrounding the former Doggerland landscape. That connection remains an area of active investigation rather than confirmed conclusion. What is clear is that the people living through that day experienced something that no accumulated knowledge in their tradition would have prepared them for. The sea had always been rising, slowly, in a way that gave time to adjust and move and carry what mattered to higher ground. That day, for the people standing on the low ground, when the water came back, it gave no time at all. Chapter 6. What the fishermen pulled up. On a Tuesday morning in the spring of 1931, a Dutch trawler working the southern North Sea pulled up its net and found, among the fish, a human jawbone. The date of that specific Tuesday is not recorded. The name of the fisherman is not recorded. The exact coordinates of where the net had been dragged are not recorded. These are the ordinary losses of an ordinary working day at sea. Undocumented, because there was no reason to document them. Because no one on that boat knew they were participating in the opening chapter of one of the most unusual archaeological stories of the 20th century. What is recorded is the bone, and what the bone eventually revealed, through the patient work of scientists who examined it over the following decades, is that it belonged to a person who had lived in the Doggerland landscape thousands of years before the sea arrived to cover it. That is the character of the accidental archaeology of the North Sea. Discovery without context. Evidence without excavation. A record assembled not from planned investigation but from the accumulated accidents of an industry that was looking for something else entirely. The objects recovered from the North Sea floor fall into several broad categories, each of which tells a different part of the Doggerland story. The faunal remains are the most numerous. Bones of woolly mammoth, woolly rhinoceros, giant deer, aurochs, red deer, horse, and other Pleistocene and early Holocene fauna have been recovered in large quantities from North Sea trawling operations, particularly in the areas around the Dogger Bank and the southern North Sea. The Dutch fishing port of Urk became, over the course of the 20th century, an informal repository of such material, with fishermen bringing in bones and teeth and tusks, recovered incidentally during normal fishing operations. The mammoth remains deserve particular attention. Several relatively complete mammoth tusks have been recovered from the North Sea bottom, some measuring more than 2 meters in length. These are not simply interesting fossils. They are direct evidence of a landscape that supported large populations of megafauna during the periods when it was above sea level. A mammoth tusk on the seafloor of the North Sea is a physical remnant of a world in which the ground, now covered by 30 meters of water, was grassland and woodland, where elephantine animals grazed in numbers. We can only estimate from the abundance of their remains. But the faunal material, impressive as it is not the most significant category of finds from a human history perspective. The worked objects are what matter most. The harpoon points are the most consistently remarkable, made from bone and antler, barbed along one or both edges, shaped with a precision that reflects long mastery of the craft. These objects have been recovered from North Sea trawling operations at multiple sites over many decades. They are not crude or experimental. They are the products of a mature technological tradition, refined through generations of practical use. The barbing is precise. The base is shaped for reliable hafting. These are tools made by people who knew exactly what they needed and exactly how to make it. The most significant collection of such material was assembled through the sustained efforts of Dutch fishermen and researchers along the Dutch coast. Jan Glimmerveen, a Dutch amateur archaeologist who spent decades cataloguing and studying material recovered by Dutch fishermen, assembled a collection that became one of the most important bodies of evidence for the human occupation of Doggerland. Glimmerveen worked with fishermen directly, encouraging them to preserve unusual finds rather than discarding them, and developed relationships with fishing crews that brought him a steady supply of material over many years. His work, conducted largely outside the formal academic system, but documented carefully enough to be scientifically useful, represents exactly the kind of bridge between popular engagement and professional research that the accidental archaeology of the North Sea has always required. Among the objects in these collections, the barbed antler point recovered from the Brown Bank area stands out, found in association with a fragment of peat that allowed radiocarbon dating to approximately 11,500 years ago. It is one of the earliest directly dated artifacts from the Doggerland landscape. It places human activity in this area of the southern North Sea within a few centuries of the end of the Younger Dryas Cold period. The people using that harpoon were among the first generation to inhabit a landscape that had only recently become livable by the standards of a new, warmer world. A piece of worked wood recovered from the same general area represents the rarest and in some ways most evocative category of find from the North Sea bottom. Wood does not survive in marine conditions except under very specific circumstances of low oxygen and stable temperature. Its presence in the North Sea assemblage, even in fragmentary form, hints at a material culture far more extensive than the surviving stone and bone objects alone would suggest. Mesolithic communities used wood for handles and hafts, for structural elements in shelters, for boats and paddles and fish traps, and 100 other purposes that the terrestrial archaeological record almost never preserves. In the anaerobic mud of certain parts of the North Sea floor, some of that wood survived. The human remains recovered from the North Sea are sparse but significant. The 1931 jawbone was followed by other finds across subsequent decades, including fragments of skull and long bone recovered from various locations in the southern North Sea. Each of these represents an individual person whose life ended in the Doggerland landscape and whose remains were preserved in the seafloor sediment long enough to be recovered thousands of years later. These are real people, not abstractions or demographic categories. People who made and used the harpoon points and worked bone objects that appear in the same collections. People who organized their lives around the rivers and wetlands and coastal margins of a landscape that no longer exists above the waterline. It is worth being honest about the limitations of this archive. An unknown quantity of significant material has gone back over the side of North Sea fishing vessels over the past century. Unrecognized, undocumented, returned to the seafloor or to the sea. The material that survived is what happened to find its way to people who recognized its significance, or who had the foresight to preserve unusual finds, even when they did not understand exactly what they had. That imperfection is part of the record. The accidental archaeology of the North Sea is valuable, not because it is systematic, but because it is all we have from most of the submerged Doggerland landscape. And even in its fragmentary and contextually compromised form, it tells us things that no other source can. It tells us that people were there, that they made things and used them, and lost them, and died there. The harpoon points in museum collections in the Netherlands. The worked wood, the bones of the animals they hunted, are the material traces of a world that existed, not the world of the specific woman imagined in the opening of this story. We will never recover her specifically, but the world she was part of, preserved in fragments by the sea that took everything else. The fishermen pulling these objects from their nets were not finding debris. They were finding, in a sense, the only testimony that world was ever able to leave. Chapter 7. Reading the Seafloor. In the early 1990s, a drilling platform operating in the central North Sea brought up a core sample from the seafloor. Somewhere in the sediment column, the drill had passed through a layer of dark organic material, peat, compressed and preserved beneath meters of marine sediment. The geologists noted it. They were looking for oil. The peat was not oil. They moved on. That core sample, and thousands like it, retrieved across decades of industrial survey work, sat in archives managed by oil and gas companies across the United Kingdom, Norway, and the Netherlands. The data it contained was real and retrievable. But the question that would have made it archaeologically meaningful: what had grown in that peat? What animals had walked across the surface above it? What people had lived near the lake or river margin where it formed? Was not a question that the industry had any reason to ask. It was not a question that archaeology had developed the tools to ask of industrial geophysical data either. Not yet. For most of the history of Doggerland research, the fundamental problem was simple and seemingly intractable. The evidence was underwater. Not underwater in the sense of a shallow coastal site, accessible to divers with good visibility and a few hours of bottom time. Underwater in the sense of the central North Sea. Cold, turbid, affected by strong currents and storm action, with water depths ranging from 20 to more than 100 meters depending on location, and with a sea floor that in many areas had been repeatedly disturbed by decades of commercial trawling. For decades, this meant that the archaeology of Doggerland was almost entirely dependent on the accidental finds described in the previous chapter. Objects recovered without context, without associated material, without the spatial relationships that allow archaeologists to reconstruct how people actually organized their lives on a landscape. You could say people were there. You could say they made sophisticated tools. But you could not say where their settlements were, or how those settlements were arranged, or what the landscape around them actually looked like at the specific moment of occupation. The transformation of Doggerland research that has occurred since the early 2000s is the product of a technology that was not developed for archaeology at all. The oil and gas industry has been conducting detailed geophysical surveys of the North Sea seafloor since the 1960s, mapping the subsurface geology in search of hydrocarbon reservoirs. This work produced an enormous archive of seismic survey data, covering vast areas of the North Sea at a resolution sufficient to image geological structures tens of meters below the seafloor surface. For decades, this archive sat in the databases of oil companies and government geological surveys, consulted for its intended purpose, and largely ignored by archaeologists who had no tradition of working with seismic data and no infrastructure for processing and interpreting it. The key figure in changing that situation was Vince Gaffney of the University of Bradford. Gaffney, an archaeologist whose career had been built on the application of remote sensing and spatial analysis to archaeological problems, recognized in the late 1990s that the seismic data archive of the North Sea contained, embedded within its geological information, a record of the Doggerland landscape, the same survey data that oil companies use to identify subsurface rock formations also imaged the surface of the seafloor and, in many cases, the buried channels and sedimentary structures of the former Doggerland topography just below that surface. The challenge was accessing the data and developing the methods to extract archaeological information from it. Gaffney and colleagues began negotiating access to seismic survey data held by oil companies operating in the North Sea. Several major operators agreed to provide access to survey data from their concession areas for research purposes. The data that came from these negotiations was substantial. Many thousands of line kilometers of seismic survey data, representing the accumulated product of decades of geological investigation, became available for archaeological analysis. Processing and interpreting this data required the development of new analytical approaches that combined the methods of seismic stratigraphy, the geological discipline concerned with reading the history of sediment deposition from seismic profiles, with the methods of landscape archaeology, the archaeological discipline concerned with understanding how people organized themselves across a landscape, rather than simply within individual sites. The results of this work, first presented publicly in 2007, and subsequently elaborated in a series of publications, culminating in the Europe's Lost Frontiers project, funded by the European Research Council between 2015 and 2019, were the first systematic maps of the Doggerland landscape ever produced. What those maps showed was not a featureless plain. It was a complex and varied landscape with a legible topography. River channels snaking across the interior, some of them major watercourses fed by the ancestral Thames from the west and the ancestral Rhine from the southeast. Enclosed basins that had held lakes. Coastal embayments where estuaries had developed as the sea advanced. Areas of higher ground, including the elevated terrain of what is now Dogger Bank, standing above the surrounding plain. The river systems were among the most striking features revealed by the mapping. The central river of the Doggerland landscape, the major watercourse, draining the interior northward toward the open ocean, had tributaries feeding into it from both the British and continental sides. The system had the character of a mature drainage network, developed over thousands of years when the landscape was above sea level and precipitation falling across it drained through an integrated river system rather than directly into the sea. The lake basins identified in the reconstruction were another significant finding. Still water environments are among the most productive habitats in any temperate landscape. They concentrate fish, waterfowl, and the mammals that come to drink and feed at their margins. For Mesolithic communities, a large lake, with extensive shallow margins, was one of the most valuable features a landscape could offer. The Europe's Lost Frontiers project, which ran from 2015 to 2019 under Gaffney's direction and involved collaborators from multiple British and European universities, represented the most ambitious attempt to date to move beyond mapping and toward actual sediment sampling and environmental reconstruction. The project used a research vessel equipped with sub-bottom profiling equipment combined with sediment coring capabilities, targeting specific locations in the Doggerland landscape, where the mapping suggested high potential for preserved sedimentary sequences. The results of the coring program were significant. Several cores recovered from targeted locations contained organic-rich sediments dating to the Mesolithic period. Before the inundation, analysis of pollen and plant macrofossils from these cores allowed the project team to reconstruct local vegetation at specific points in the Doggerland sequence. The picture that emerged showed hazel woodland, reed beds along river margins, and aquatic plants in shallow lake environments, a mosaic of habitats, diverse and productive, arranged across a landscape of considerable topographic variety. The project also used environmental DNA techniques, extracting ancient genetic material from sediment samples and using it to identify the organisms present at the time of deposition. This approach, still relatively new in archaeological applications, but developing rapidly, produced signatures of fish species, aquatic invertebrates, and terrestrial mammals, building a picture of the Doggerland fauna that complements the faunal remains recovered from trawling operations. Whether any cultural features, the physical remains of human activity on the former land surface, have been confidently identified in the Doggerland seafloor. From survey work alone is a question on which the research community is appropriately cautious. The taphonomic processes that have acted on the former land surface over 8,000 years of marine inundation, erosion, sedimentation, and trawling disturbance have substantially altered and in many areas destroyed whatever surface expression any former settlement or activity area might have had. Features that might be archaeologically significant require corroboration from subsurface sampling before any confident interpretation is possible. That caution reflects good science rather than a failure of ambition. Knowing when to claim a discovery and when to reserve judgment is one of the most important disciplines in field archaeology, and it applies with particular force in an environment as challenging as the North Sea seafloor. What can be said with confidence? After 2 decades of systematic investigation using modern geophysical methods, is this? The landscape exists. It is documented by multiple independent lines of evidence that converge on a consistent picture of a complex and productive former world now lying beneath the North Sea. The questions that remain unanswered are large. Where were the settlements? How were they organized? Where did people gather at the confluences of those mapped rivers? These questions cannot yet be answered from the available evidence, but they can now be asked in a way that is scientifically meaningful, with methods capable of beginning to pursue answers. Somewhere in that cold, dark water, in a lake basin, or a river bend, or a tidal channel that the seafloor maps are only now revealing, there may be a fish trap, built from woven branches and wooden stakes, set in a current that stopped flowing 8,000 years ago by hands we cannot name. In a world we are only beginning to find. We have not found it yet, but for the first time, we are looking in the right places. Chapter 8. Rivers, lakes, and a landscape recovered. There is a specific kind of knowledge that takes years to accumulate and seconds to lose. A fisherman who has worked the same stretch of river for 40 years knows things about that river that no map can capture. Where the current shifts in a dry summer, which bend holds fish in cold weather and which holds them in warm. Where the bank is stable and where it undercuts. Where the fog settles first in autumn and where it clears last in the morning. That knowledge lives in the body as much as in the mind. It is inseparable from the specific ground that produced it. Move that fisherman to a different river, even a similar one, and most of what he knows becomes useless. The knowledge was not about rivers in general. It was about that river, that specific water moving through that specific landscape. The communities of Doggerland had that kind of knowledge, accumulated across generations. refined through lifetimes of observation, tested against the reality of specific places in a specific landscape. Knowledge of rivers and lakes, and the seasonal rhythms of a world that is now under 30 meters of seawater. We cannot recover that knowledge directly. It died with the people who held it, and the landscape that made it meaningful. But we can recover something of the landscape itself. And from the landscape, we can begin to understand what that knowledge would have been about. The river systems of Doggerland are among the most significant features of the reconstructed landscape, and among the aspects that modern research has documented with the greatest confidence. The geophysical survey data, analyzed by Gaffney and colleagues at the University of Bradford, combined with sediment core evidence from the Europe's Lost Frontiers project, allows a reconstruction of the major drainage patterns of the Doggerland landscape that is detailed enough to be ecologically meaningful. The central organizing feature of the Doggerland river system was a major watercourse, draining the interior northward toward what was then the open ocean. This river, identifiable in the seismic survey data as a broad channel cutting through the sedimentary sequence of the southern North Sea basin, was not a minor stream. It was a substantial river, fed by tributaries, draining large catchment areas on both the British and continental sides of the former land bridge. From the west, the ancestral Thames contributed its flow. The Thames of 12,000 years ago was a considerably larger river than its modern descendant, because the catchment it drained extended further west across what is now the English Channel. From the southeast, the ancestral Rhine made its contribution, flowing northwestward across the exposed continental shelf before joining the central Doggerland river system. What is now a coastline dotted with separate river mouths was once a single unified drainage system, emptying through a common outlet far to the north of any present land. The confluence of the ancestral Thames and the ancestral Rhine within the Doggerland landscape would have been a major hydrological feature. A broad river junction where two of the largest river systems of northwestern Europe met, before emptying into a sea still considerably further north than it is today. River confluences are among the most consistently significant locations in the archaeology of hunter-gatherer societies. The junction of two major rivers creates a concentration of resources that neither river provides alone. Fish moving upstream from the sea encounter a junction and must choose a branch, creating a natural funnel that human fishers can exploit with particular efficiency. Animals coming to drink are concentrated at the broader water body that confluence creates. The flat alluvial ground on the inside of river bends is among the most productive foraging ground in any temperate landscape. Whether the confluence of the ancestral Thames and Rhine in the Doggerland landscape was a site of intensive human occupation is something the available evidence cannot yet confirm. The location is now under several tens of meters of North Sea water, and no targeted archaeological investigation of that specific location has been conducted. But the ecological logic is compelling, and the inference that this would have been one of the most intensively used locations in the entire Doggerland landscape is consistent with everything known about how Mesolithic communities related to river systems across northwestern Europe. The lake basins identified in the Doggerland reconstruction are a second major category of ecologically significant features. Several substantial enclosed basins have been identified in the geophysical survey data. Areas where the former land surface shows a depression that would have held standing water. The largest of these, located in the central area of the former Doggerland landscape, has been estimated at several tens of kilometers in its longest dimension, making it a lake comparable in size to some of the larger lakes in modern Britain and Scandinavia. Lakes of this size in a temperate post-glacial landscape are not simply large bodies of water. They are ecological engines. The shallow margins where sunlight penetrates to the bottom and aquatic vegetation grows in abundance support extraordinary concentrations of fish, waterfowl, and the mammals that depend on wetland environments. The reed beds and sedge marshes that develop along lake margins are among the most productive natural habitats in any temperate region. For Mesolithic communities with a diversified foraging strategy, a large lake with extensive shallow margins was one of the most valuable features a landscape could offer. The sediment core evidence from the Europe's Lost Frontiers project adds biological detail to the topographic reconstruction. Cores, extracted from locations corresponding to former lake basins, have recovered organic sediments containing pollen assemblages, plant macrofossils, and environmental DNA that allows reconstruction of the biological communities present at the time of deposition. The pollen evidence from these cores tells a story of progressive ecological change across the period of Doggerland occupation. The earliest post-glacial sediments contain pollen dominated by birch and pine, the pioneer tree species that colonize open ground as temperatures rise following glacial conditions. Moving up through the cores, hazel becomes increasingly prominent, reflecting the expansion of hazel scrub across the landscape as conditions warmed. Then oak, elm, lime, and the other species of the Atlantic mixed forest begin to appear, indicating the development of dense woodland during the middle phases of Doggerland occupation. Hazel deserves particular attention in this context. Hazelnut is one of the most important plant foods documented at Mesolithic sites across northwestern Europe. It is highly nutritious, storable over winter, and produced in abundance in good years by hazel shrubs growing in woodland edge habitats. The expansion of hazel across the Doggerland landscape, documented in the pollen record, would have been a significant development for the communities living there. Hazel-rich woodland edge habitat is exactly the kind of environment that Mesolithic communities targeted intensively, returning seasonally to harvest the nut crop and process it for winter storage. Charcoal particles appear in some of the Doggerland sediment cores, and their presence raises a question worth examining. Charcoal in lake sediments can come from natural fires ignited by lightning, or from human fires burning on the landscape around the lake. The presence of charcoal in contexts where the pollen record also shows disruption of woodland cover is a pattern that archaeologists at terrestrial sites across northwestern Europe have interpreted as possible evidence of deliberate burning to manage vegetation. Whether the charcoal in the Doggerland cores reflects deliberate burning by Mesolithic communities is a question the current evidence cannot definitively answer. The sample sizes are limited, and the spatial resolution of the coring program is not sufficient to distinguish between a single, large, natural fire and a pattern of small, targeted burns. The question remains genuinely open. But consider what it would mean if deliberate burning was occurring. It would mean the landscape was not simply a natural backdrop to human lives. It was partly a product of human intervention, shaped over generations by deliberate decisions about what to encourage and what to suppress. The loss of Doggerland was then not only the loss of a natural landscape and the communities living within it. It was the loss of a managed landscape, shaped by accumulated knowledge that took generations to build and that could not survive the displacement of the people who held it. The rivers and lakes of Doggerland are gone now. The peat that formed in their margins is preserved in some areas beneath the North Sea sediments, waiting in the cold dark for cores and sampling devices that can recover a fraction of what it contains. The landscape that those water bodies organized and sustained exists now only in the geophysical data and the sediment records, and the occasional object brought up by a fishing net that dragged across the right part of the seafloor at the right moment. But the reconstruction is real. The rivers were real. The lakes were real. The forests and reed beds and hazel scrub and productive wetland margins were real. Somewhere on the bank of that central river, beside a lake whose name we will never recover, someone set a fish trap in the grey light before dawn and waited to see what the water had kept. We are still waiting to see what the water has kept for us. Chapter 9. The problem of memory. Consider what it would mean to lose a landscape, not lose it abstractly, in the way we speak of losing something we never personally had. Lose it, the way the communities of Doggerland lost it. The specific river bend where the fish ran best in spring. The particular stand of hazel that could be counted on in autumn. The sheltered inlet where the seals hauled out in summer, and where children learned the patience that seal hunting requires. Specific places, with specific names in a language we will never recover, known in the particular embodied way that a lifetime of return and observation creates. When those places went under the water, the names went with them, the knowledge went with them, but something else may have remained, something that the sea, for all its patience and all its thoroughness, could not quite reach. Story. The question of whether any oral traditions preserved from the time of Doggerland's inundation survive in recognizable form today is one of the most genuinely uncertain in the entire field. It sits at the intersection of archaeology, linguistics, oral history, and the study of human memory, and it resists easy answers in ways that demand both intellectual honesty and genuine curiosity. The methodological foundation for approaching this question carefully comes from work published in 2015 by Patrick Nunn of the University of the Sunshine Coast and Nicholas Reed of the University of New England. In a paper in the Journal of Archaeological Science, Nunn and Reed examined oral traditions from multiple indigenous communities around the Australian coastline that described specific geographic features, not vague catastrophes or moral narratives about divine punishment. Specific places, specific transformations of specific landscapes that could be checked against the independent geological and oceanographic record of post-glacial sea level change. What they found was that a significant number of these traditions described, with geographic precision that was locationally verifiable, the inundation of land that had indeed been above sea level during the period when the stories were calculated to have originated. Land, now underwater, was described as former dry ground. Bays were described as former valleys. Islands were described as former hilltops. And the timing of the described changes, when compared with the known chronology of sea level rise in those specific locations, was consistent with the events having occurred between 7,000 and 10,000 years ago. The paper was carefully framed. Nunn and Reed were not claiming that all oral traditions are historically reliable. They were making a much more specific argument, that oral traditions attach to specific geographic features, traditions in which the described event can be independently verified by comparing the story with the physical record, can preserve accurate information across spans of time previously considered beyond the reach of oral memory. The key word is specific. Geographic specificity is what makes independent verification possible. It is what distinguishes traditions that might carry genuine environmental memory from those that simply express the universal human experience of loss and disruption through narrative. This framework is the appropriate foundation for any serious engagement with the question of whether oral traditions might preserve memories of Doggerland. And when applied honestly to the available traditions, it produces results that are suggestive in some cases, clearly insufficient in others, and always short of the kind of confirmation that would justify strong claims. The oral traditions of the peoples living around the North Sea basin are rich with stories about land lost to the sea. The legend of Lyonesse, the land west of Cornwall, supposedly swallowed by the sea. The Dutch legends of drowned lands accumulated from multiple centuries of coastal flooding. The Norse traditions of catastrophic inundation associated with the end of a previous age. On casual inspection, the abundance of these traditions in precisely the regions surrounding the former Doggerland landscape might seem significant. But the Nunn and Reed framework requires more than thematic correspondence. It requires geographic specificity. And when the available traditions from the North Sea region are examined against that standard, the picture becomes considerably more complicated. Most of the widely known North Sea land loss traditions are not geographically specific in the way that the Australian traditions were specific. The legend of Lyonesse does not describe a specific valley that became a specific bay at a specific time that can be checked against the sea level record. The geological record of the western approaches to Cornwall does not straightforwardly support the existence of a large inhabited landmass inundated within the period when oral tradition might plausibly preserve the memory. The traditions that come closest to meeting the specificity standard for the North Sea region are not the grand legendary narratives but smaller, more local, more geographically grounded stories preserved in some coastal communities. Traditions among some communities on the east coast of England about specific features of the seafloor, about where the fishing is good, because there used to be a forest there, are the kinds of detail the framework considers potentially worth examining. Whether any of these localized traditions actually preserve memories of Doggerland, or whether they represent the common human tendency to explain the presence of organic material in fishing nets through the most immediately logical narrative, is a question that cannot currently be resolved. There is one tradition that has attracted particular scholarly attention. Among certain communities in the Netherlands and along the Flemish coast, there are stories describing a great flood that came from the north and took a land that had been populated and productive. The directionality of this tradition is intriguing in the context of the Storegga tsunami, which would have arrived in the southern North Sea from exactly that direction. A tsunami generated off the Norwegian coast, propagating southward, would have arrived at the shores of what is now the Netherlands from the north. The correspondence between the directional detail in some versions of this tradition and the known directionality of the Storegga event is the kind of specific detail that the Nunn and Reed framework identifies as potentially worth examining further. It is not proof of anything. The same directional detail could reflect later historical flood events, of which the North Sea region has experienced many, or independent cultural logic, associating danger with the north, in a region where North Sea storms consistently arrive from that direction. But it is the kind of detail worth noting, carefully and without overstatement. The broader point this chapter has been building toward is not that oral traditions confirm the existence of Doggerland or the specific events of its inundation. The physical record does that work entirely on its own. The broader point is about the nature of human memory and the way communities process the experience of catastrophic loss. The people who lived through the drowning of Doggerland were not geologically informed. They did not know why the sea was rising. They knew that the land was shrinking, that places their grandparents had named were now underwater, that the world was getting smaller in a way that had no obvious cause and no apparent end. They told stories about that. Human beings make narratives out of the most significant experiences of their lives, and the loss of a homeland is among the most significant experiences any community can undergo. Those stories entered the oral tradition and were passed forward, changing as they traveled, absorbing new elements and losing old ones, until the specific details that would make them independently verifiable were buried under layers of symbolic elaboration and cultural overlay. Whether any of those original stories survive in forms we can still recognize is the question the Nunn and Reed framework offers the best current method of approaching. That method has not yet been systematically applied to the North Sea region. When it is, the results may be illuminating or they may be disappointing. The honest answer at this point is that we do not yet know. What we do know is that the loss was real, that people experienced it over generations in ways that demanded narrative responses, that those responses entered the oral tradition of Northwestern European cultures and contributed, in ways we cannot currently fully trace, to the landscape of story and memory those cultures carried forward. The sea took the land. The people made stories about it. Some version of those stories is almost certainly still out there, embedded in traditions we have not yet learned to read correctly. Finding them, and verifying them, and understanding what they actually preserve from the experience of a world drowned 8,000 years ago, is work that has not yet been done. It deserves to be. Chapter 10. The 8.2 Kiloyear event. There are moments in the climate record that stand apart from the general noise of natural variability. Moments when the data from multiple independent archives, ice cores and lake sediments and marine records and tree rings, converge on the same signal at the same time. When that convergence is tight enough and the signal is clear enough, what it represents is not an artifact of any single measurement system. It is something that actually happened to the climate of the Earth. The event that paleoclimatologists refer to as the 8.2 Kiloyear event is one of those moments. 8.2 Kiloyear means 8,200 years ago. The naming convention is dry and technical in the way that scientific shorthand often is, giving no indication of the human reality behind it. But the event itself, in terms of its speed, its magnitude, and is anything but dry. The 8.2 Kiloyear event was a rapid and pronounced cooling episode that interrupted the general warmth of the early Holocene. It was not a return to full glacial conditions, but it was, by the standards of the Holocene, a significant and abrupt departure from the warming trend that had been underway since the end of the Younger Dryas. The ice core records from Greenland, analyzed by researchers including Sigfus Jonsson of the University of Copenhagen and colleagues, show a temperature drop of somewhere between 1 and 3 degrees Celsius, occurring within a period of decades and persisting for approximately 160 years before conditions returned to the warmer trajectory of the Holocene. 1 to 3 degrees averaged across the hemisphere translates, at the regional scale in northwestern Europe, into considerably more severe local effects. Winters significantly colder than those either before or after the event. Growing seasons shortened at both ends. The woodland communities that had been expanding northward and to higher elevations during the early Holocene warmth pushed back toward lower latitudes and altitudes. The wild plant foods that Mesolithic communities depended on became less reliable and less abundant. The mechanism behind the 8.2 Kiloyear event is now reasonably well understood. The most widely accepted explanation involves the catastrophic drainage of large proglacial lakes, Lake Agassiz and Lake Ojibwe, that had accumulated meltwater at the margin of the retreating Laurentide ice sheet in what is now central Canada. When the ice dams holding those lakes finally failed, the fresh water they had been holding was released into the North Atlantic Ocean in a pulse of extraordinary magnitude. The consequence of injecting that volume of cold, fresh water into the North Atlantic was a disruption of the Atlantic meridional overturning circulation, the ocean current system that distributes heat from the tropics toward the higher latitudes of the northern hemisphere. When that circulation slows, the heat transport it normally provides to the North Atlantic region is reduced, and temperatures in northwestern Europe fall. Within approximately 160 years, the circulation recovered and temperatures returned to the warming trajectory of the Holocene. The event was severe but relatively brief compared with the 1,200 years of the Younger Dryas. 160 years is brief in geological terms. In human terms, it is between 5 and 8 generations, long enough for children born into the cold to grow old and die without having experienced anything different. Long enough for the memory of how the world had been before the cooling to become something that only the very old could speak about from their own experience, and something that everyone else knew only through the stories those old people told. Now place this event in the context of what was already happening in Doggerland. By 8,200 years ago, the Doggerland landscape had already been substantially reduced by ongoing sea level rise. The surviving above sea level terrain was concentrated on higher ground, including the island or near island of Doggerbank. And in the same general period, the Storegga tsunami had struck. The precise temporal relationship between the Storegga slide and the 8.2 Kiloyear event is not definitively established by the available dating evidence. The Storegga slide has been dated by various methods to approximately 8,100 to 8,200 years ago. The 8.2 Kiloyear event is dated to approximately the same period. Whether these two events were essentially simultaneous, or separated by a few decades, or whether one may have influenced the conditions for the other, is not currently confirmed. What is established is that they fall within the same broad temporal window. The communities of the Doggerland landscape, already under pressure from progressive sea level rise, experienced within what may have been a single human lifetime, both a catastrophic tsunami and the onset of a significant cooling episode that would last for 5 to 8 generations. The ecological consequences of the 8.2 kiloyear cooling for the surviving Doggerland landscape were severe. Wild plant foods are highly sensitive to growing season length and temperature. A cooling that shortens the growing season at both ends reduces the productivity of these resources significantly. The woodland habitats supporting the terrestrial game of the Doggerland landscape were disrupted by the same cooling, with tree species retreating from the margins of their ranges. At the same time, the sea level rise continued. The cooling of the 8.2 kiloyear event may have temporarily slowed the rate of ice sheet melting and therefore the rate of sea level rise. But it did not stop or reverse it. The long-term trajectory of inundation was not altered by the cooling. It was simply continued while the communities attempting to survive on the shrinking landscape also faced reduced ecological productivity from the cold. The ancient DNA record of European Mesolithic populations across this broad period shows patterns consistent with substantial regional demographic change. Researchers, including Wolfgang Haak of the Max Planck Institute for Evolutionary Anthropology, have documented genetic patterns in Mesolithic human remains, suggesting this was a period of significant demographic flux and regional restructuring across parts of northwestern Europe. It is important to be clear about what this evidence does and does not show. The genetic record indicates regional scale change and complexity during this period. But linking specific demographic shifts directly and precisely to the Doggerland inundation alone, as distinct from the broader suite of environmental pressures operating simultaneously, remains difficult with current evidence. The picture is one of substantial change whose exact causes and mechanisms are still being investigated. What the convergence of these pressures meant in human terms was this: communities that had maintained their size and social complexity across the preceding millennia were operating under conditions that placed every aspect of their lives under simultaneous stress. When communities are reduced, the specialists who hold particular forms of knowledge become more vulnerable to loss. The knowledge of which plants grow where and when, the understanding of specific river behaviors in specific seasons, the practical expertise that took a lifetime to develop and required a community large enough to sustain people whose work was not directly producing food. When those specialists are gone, the knowledge goes with them. The 8.2 kiloyear event was not only a climatic episode. In the context of the Doggerland story, it was the final compounding stress in a sequence of pressures that remade the human landscape of northwestern Europe. What survived that remaking was not everything that had existed before. But some things did survive. People survived. And with them, enough of the essential knowledge and social capacity to eventually, when conditions improved, begin the long process of rebuilding. What that rebuilding looked like is the story the next chapter tells. Chapter 11. Where the survivors went. For most of the history of archaeology, the question of where people went when a landscape became uninhabitable could only be answered indirectly. You looked at what disappeared from the archaeological record in one place and what appeared in another, and you drew inferences about movement based on similarities in material culture. The inferences were often reasonable. They were also often wrong in ways that were difficult to detect. The development of ancient DNA analysis has changed this situation in ways that are genuinely significant for understanding the Doggerland story. Ancient DNA is genetic material extracted from the bones or teeth of individuals who died long ago. In favorable conditions, it can survive for tens of thousands of years. The techniques for extracting, sequencing, and interpreting ancient DNA have advanced with extraordinary speed since the early 2000s. Driven partly by improvements in sequencing technology, and partly by the development of computational methods for dealing with the degraded and fragmentary nature of ancient genetic material. Research groups led by David Reich of Harvard University, Johannes Krauss, and Wolfgang Haak of the Max Planck Institute for Evolutionary Anthropology, and Eske Willerslev of the University of Copenhagen, among others, have analyzed ancient DNA from hundreds of individuals spanning the European Mesolithic and Neolithic periods. The picture that has emerged is one of considerable complexity, involving multiple episodes of population movement, mixture, and restructuring that the purely archaeological record had not fully revealed. The genetic profile of Mesolithic hunter-gatherers in Western Europe, characterized by specific combinations of genetic variants that researchers refer to as the Western hunter-gatherer ancestry component, is distinct from that of the farming populations, who subsequently spread into Europe from Anatolia, beginning around 9,000 years ago. This distinction allows researchers to trace the Western hunter-gatherer genetic signal through the archaeological record and identify where populations carrying it were present at different points in time. The Western hunter-gatherer ancestry is found in Mesolithic individuals across a wide geographic range in Europe, from Britain and Scandinavia in the northwest to the Balkans in the southeast. It represents the genetic legacy of the people who inhabited post-glacial Europe before the arrival of farming, and it includes, by geographical inference, the communities of the Doggerland landscape. The specific genetic profile of individuals from Doggerland itself cannot be directly assessed because no ancient DNA has been successfully extracted from the human remains recovered from the North Sea floor. The preservation conditions for DNA in marine-influenced sediments are generally poor, and the material available from trawling finds is typically not in the condition required for successful ancient DNA extraction. But populations genetically related to the Doggerland communities can be traced in the DNA of individuals from the surrounding regions. Mesolithic individuals from Britain, from Scandinavia, and from the Netherlands and Belgium show genetic profiles consistent with their being part of the same broadly connected population that would have included the Doggerland communities. As the Doggerland landscape was progressively inundated and its population was forced to relocate, the movement of those people onto the surrounding higher ground would have been a movement of closely related people into closely related populations, genetically difficult to distinguish from the regional continuity already present. What the ancient DNA record shows with considerable clarity is that this was not a simple or uniform process. The genetic diversity of Western hunter-gatherer populations in northwestern Europe shows patterns of regional differentiation and restructuring across the Mesolithic sequence, reflecting significant population movement and mixture over time. The Western hunter-gatherer ancestry did not disappear with the inundation of Doggerland. It persisted. It is present in the genetic record of populations across Europe after the Mesolithic, mixed to varying degrees with the incoming Anatolian farmer ancestry that arrived with the spread of agriculture and, later, with the steppe ancestry associated with Bronze Age migrations from the east. In northwestern Europe today, people of British, Dutch, Danish, and German ancestry carry genetic contributions from multiple ancestral populations across these successive waves, of which the Western hunter-gatherer component is one layer among several. It is important to hold that complexity honestly. The people of Doggerland became part of the ancestry of later European populations. That is accurate. The fuller picture requires acknowledging that the history of European populations since the Mesolithic involves too many subsequent layers of migration and mixture for any single ancestral group to be described as the direct origin of any modern population. There is another form of inheritance that the genetic record cannot directly measure. The knowledge that the Doggerland communities carried with them when they moved to higher ground was not lost entirely. The specific knowledge of particular river systems and lake margins rendered obsolete by the inundation of the landscape it described. That specific knowledge could not survive the loss of its ground. But the deeper knowledge, the understanding of how to read a landscape for its productive resources, how to organize communities for the exploitation of diverse and seasonally variable food sources, how to maintain the social bonds that allow specialized knowledge to persist across generations. That deeper knowledge was transferable. How that knowledge eventually shaped the trajectories of the communities who inherited it is a question that goes beyond what the current evidence can confirm in detail. What can be said is that the survivors arrived on the shores of higher ground, not as people starting from nothing, They arrived as the inheritors of a long tradition of practical knowledge and social organization tested and refined in one of the most productive environments post-glacial Europe had to offer. They were the people who had built their lives in the center of the world. When that center went under the water, they carried what they could of it into a world that was already changing around them in ways none of them fully understood. And they kept going. Chapter 12. Why We Did Not Know Sooner. In the summer of 1998, a British archaeologist named Brian E. Coles published a paper in the Proceedings of the Prehistoric Society that gave a name to a landscape that had existed, in various forms of incomplete recognition, in the geological and archaeological literature for decades. She called it Doggerland. The paper was not greeted with the kind of attention it deserved. It appeared in a specialist journal read by a specialist community. It made an argument that required synthesizing geological evidence that most archaeologists did not work with, and archaeological evidence that most geologists did not think about. It pointed toward a research program that would require methods, funding, and interdisciplinary collaboration that did not yet exist in organized form. It took nearly a decade for the research infrastructure needed to actually investigate the landscape Coles had named to begin assembling itself. And it took another decade beyond that for the results of that investigation to reach the level of public awareness that a discovery of this magnitude arguably warranted. The question of why it took so long is worth asking carefully, because the answer reveals something important not only about Doggerland, but about how scientific disciplines develop blind spots, and how long those blind spots can persist. Archaeology, as a formal discipline developed in the 19th century, shaped by the methods and assumptions of a scholarly tradition focused on excavation. You found a site, you dug it, you recovered material, you analyzed that material and drew conclusions about the people who had deposited it. The entire logic of the discipline was organized around the assumption that the sites worth studying were accessible by walking to them and putting a trowel in the ground. That assumption was not unreasonable. The overwhelming majority of human history was enacted on dry land, and the overwhelming majority of the archaeological record is therefore terrestrial. The assumption worked well enough, for long enough, that it became embedded in the discipline as something close to an axiom, rather than a contingent methodological choice. The consequence was that the underwater world was essentially invisible to mainstream archaeology for most of the discipline's existence. Not because underwater sites were unknown. The existence of submerged prehistoric landscapes had been discussed in geological and antiquarian literature since the 19th century. Fishermen had been pulling up mammoth bones and stone tools from the North Sea and other shelf areas for generations. The basic facts about post-glacial sea level rise were understood in broad outline well before the 20th century. But understanding that a phenomenon exists, and having the conceptual and methodological infrastructure to study it systematically are two entirely different things. The reasons for this gap are worth examining. The first was practical. Underwater archaeology is extraordinarily expensive and logistically complex compared with terrestrial archaeology. A terrestrial excavation requires a site, a team, some equipment, and a permit. An underwater excavation in the North Sea requires a research vessel capable of operating in open water, specialized equipment for working at depth, acoustic positioning systems, methods for recovering and stabilizing waterlogged organic material, and a budget that dwarfs what most archaeological research projects have historically been able to access. The barrier to entry for underwater work has historically been high enough that only projects with specific and compelling justifications have been able to cross it. The second reason was disciplinary. The researchers best placed to recognize the significance of the submerged North Sea landscape. Archaeologists, working on the European Mesolithic, were trained in terrestrial methods and had built their careers around terrestrial sites. The geologists and oceanographers who understood the structure and history of the North Sea seafloor were not archaeologists and did not think in terms of human occupation and cultural landscapes. The two communities of knowledge that together could have addressed the Doggerland question were largely operating in separate professional worlds. The third reason was the nature of the evidence itself. Isolated objects of uncertain provenance, pulled from fishing nets, are genuinely difficult to use in the kind of argument that academic archaeology values most. They are interesting. They are suggestive. But they do not, on their own, constitute the kind of evidence that moves a research agenda forward in a discipline built around systematic excavation. The objects were there, in museum collections and fishermen's sheds, waiting for methods that could give them context. Without those methods, they could not speak clearly enough to compel the investment the problem required. What changed the situation was a convergence of several developments that aligned in the late 1990s and early 2000s. The development of geographic information systems capable of processing large datasets of geophysical survey data at useful scales was one. The willingness of the oil and gas industry to share seismic survey data for research purposes was another, reflecting a combination of regulatory frameworks, public relations considerations, and the personal efforts of researchers like Vince Gaffney, who built the relationships that data sharing required. The development of a funding infrastructure capable of supporting large-scale interdisciplinary research projects, culminating in the European Research Council's investment in the Europe's Lost Frontiers project, was a third. None of these developments was inevitable. Each required specific people making specific decisions at specific moments. Coles, naming the landscape. Gaffney, building the relationships to access the data. The unnamed Dutch fisherman who preserved unusual finds rather than throwing them back over the side. The scientists at institutions across multiple countries who recognized that a drowned landscape beneath the North Sea was worth the considerable effort of investigating. It is also worth acknowledging honestly what the late arrival of those people and those methods cost. The trawling disturbance of the North Sea seafloor that has been accumulating since commercial fishing with bottom-dragging gear became widespread in the late 19th and 20th centuries has caused damage to the Doggerland, archaeological record that cannot be undone. Sites that might have existed as coherent archaeological features on the former land surface have in many areas been repeatedly disturbed by trawl gear passing over them. The spatial context that would have made those sites most informative has been destroyed where the trawling pressure has been greatest. The lesson is clear. When the tools available to a discipline cannot see something, that something also cannot be protected. What was lost to trawling disturbance in the North Sea before the significance of the Doggerland landscape was fully recognized is a cost of a structural blindness that belonged to no individual failure. It belonged to the shape of the discipline at the time. That shape has changed. The methods exist. The disciplinary recognition of underwater prehistoric landscapes as legitimate and significant research environments is now well established. But it came late. And the things that were damaged or destroyed while it was still developing cannot be recovered. That is the honest accounting of what the delay cost. Chapter 13. What still lies there? The North Sea is not a static archive. That distinction matters more than it might initially seem. A buried terrestrial site in stable soil conditions can remain essentially unchanged for thousands of years. The organic material decomposes, but slowly. The spatial relationships between objects shift, but minimally. The sediment that holds everything in place does its work quietly and indefinitely, preserving what it contains until someone with a trowel disturbs it. The seafloor of the North Sea does not work that way. It is a dynamic environment, subject to currents, storm, action, sediment transport, bioturbation by burrowing organisms, and the ongoing mechanical disturbance of commercial fishing gear. These processes are not uniform across the entire seafloor. Some areas are more sheltered, more stable, more removed from the most intense disturbance. Some areas have been subject to continuous and severe disturbance for decades. The preservation potential across the Doggerland landscape is highly variable, and understanding that variability is one of the most important challenges facing the research program. The areas of highest preservation potential are, broadly speaking, those where the former land surface has been covered by subsequent marine sediment quickly enough and deeply enough to protect it from the most damaging surface processes. In parts of the North Sea where the inundation sequence produced rapid burial of the former land surface, the cold, oxygen-poor conditions that develop in the sediment below the active surface zone can be genuinely remarkable for organic preservation. The evidence for this preservation potential is not theoretical. It is demonstrated by the actual objects that have been recovered. The worked wood fragments, the barbed antler harpoon points, the peat deposits containing identifiable plant macrofossils and pollen, the human remains that retain enough structural integrity to be radiocarbon dated. These objects survived because they were in conditions that permitted survival. And where those conditions exist, there are likely many more objects still in place. Bone and antler, as demonstrated by the harpoon points and faunal remains already recovered, survive well in the anaerobic conditions of waterlogged marine sediment. The catalogue of bone and antler tools from the Doggerland landscape is almost certainly a very small fraction of what was originally deposited. Wood is the category that generates the most genuine scientific interest among researchers. And for good reason. Wood decays rapidly under almost all terrestrial conditions, which means that the wooden component of Mesolithic material culture is almost entirely invisible in the terrestrial archaeological record. We know that Mesolithic communities used wood extensively for handles and hafts, for structural elements in shelters, for boats and paddles and fish traps, and 100 other purposes that the terrestrial record almost never preserves. In the anaerobic sediments of the North Sea floor, wood can survive. The fragment of worked wood already recovered from the southern North Sea is evidence of this. The possibility of preserved wooden structures is one of the more compelling research questions currently facing the Doggerland program. Mesolithic communities in Scandinavia and Britain built fish weirs, structures made from woven branches and wooden stakes, designed to trap fish in tidal channels and river mouths. Several such structures have been found at waterlogged terrestrial sites in Britain, Denmark, and elsewhere, and their preservation is remarkable. The woven branches retain their form. The stakes are still upright. If fish weirs were built in the estuaries and tidal channels of the Doggerland landscape, some of them may survive in the anaerobic sediment of those former channels. This is a genuine possibility supported by the known preservation conditions of the North Sea seafloor and the documented use of such structures by Mesolithic communities in the surrounding region. It is a possibility, not a confirmed finding. Whether any such structures actually survive, and in what condition, is something that can only be determined through targeted subsurface investigation that has not yet been conducted at the required locations and resolution. The seafloor area corresponding to the former Doggerland landscape is enormous. Even with the most sophisticated survey methods available, systematic investigation of that entire area at the resolution required to identify specific archaeological features is a task that far exceeds the resources currently available to the research program. What is feasible is targeted investigation, using the landscape reconstruction to identify locations of high archaeological potential and focusing survey and coring work on those locations. The Europe's Lost Frontiers project worked on exactly this logic, and its results demonstrate that the approach can produce significant findings when the targeting is informed by good landscape reconstruction. Burial sites are perhaps the most humanly significant category of potential preserved material. The Mesolithic communities of northwestern Europe buried their dead with deliberate care, as demonstrated by the cemeteries at Skateholm and Vedbeek. If comparable burial practices were followed in the Doggerland landscape, intact burials may exist in the seafloor sediments. Ancient DNA from an intact Doggerland burial would be extraordinary, providing the direct genetic profile of a person from the landscape itself, rather than the indirect inference from surrounding populations that currently constitutes the best available genetic evidence. Whether any such burials exist in recoverable condition is genuinely unknown. The North Sea is a patient keeper of certain things. It has been keeping these particular things for 8,000 years. But it is not keeping them undisturbed. The ongoing disturbance of the seafloor, the acidification of seawater threatening the preservation of calcareous material, the increasing storm intensity associated with climate change, driving sediment transport, are all working against the archive. The window for recovery is open. It is not indefinitely open. Imagine the fish trap one more time. Built from woven branches and wooden stakes, set in a current that stopped flowing 8,000 years ago by hands that knew exactly what they were doing. In the cold and the dark and the pressure of the deep, the conditions that preserved the harpoon points and the worked wood may have preserved it too. We do not know. We cannot know without looking. But the looking is underway, and the archive, whatever it still contains, will not wait forever. Chapter 14. When the water rises again, there is a particular discomfort that comes from recognizing a pattern you thought belonged to the distant past in the world directly around you. Not the comfortable discomfort of an interesting historical parallel. The sharper kind. The kind that arrives when the distance between then and now collapses. And what you thought was a story about people who lived 8,000 years ago becomes, with a shift in perspective, a story about the situation you are currently in. Doggerland is that kind of story. The sea level rise that drowned Doggerland was driven by the melting of large ice sheets in response to a warming climate. The warming of that period was driven by changes in the Earth's orbital relationship to the Sun. Slow astronomical cycles, operating on timescales of tens of thousands of years. The process was natural in the sense that it was not caused by anything the people of Doggerland did or failed to do. They had no agency over the forces that took their world. The ice melted. The sea rose. The land disappeared. The sea level rise currently underway is also driven by the melting of large ice sheets and the thermal expansion of warming ocean water. The warming driving it is not the product of slow orbital cycles. It is the product of changes in atmospheric composition driven by human industrial activity across the past 2 centuries. The mechanism is the same. The cause is different. The Intergovernmental Panel on Climate Change, in its assessment reports, synthesizing the work of thousands of researchers across multiple disciplines, has documented with high confidence that global mean sea level has been rising throughout the 20th and 21st centuries, and that the rate of rise has been accelerating. The most recent assessment places the rate of rise over the period from 2006 to 2018 at approximately 3.7 millimeters per year. It is important to be precise about what this number means in relation to the Doggerland story. The rate of current sea level rise is lower than the fastest phases of post-glacial rise, which, during periods like meltwater pulse 1a, reached rates estimated at many times the current figure, and which, during the period most relevant to Doggerland, averaged around 10 to 20 millimeters per year in the affected region. The current rate is not, by itself, faster than what the people of Doggerland faced during the most intense phases of their world's inundation. What makes the current situation genuinely different is not the rate of rise considered in isolation. It is the combination of an accelerating rate, a trajectory pointing toward continued increase, and a world whose major cities, river deltas, and coastal communities are already sitting at or very near sea level. The vulnerability is determined not only by how fast the water rises, but by the height of the ground people are standing on, and by how much time there is to respond before that ground becomes uninhabitable. Projections for future sea level rise depend on trajectories of greenhouse gas emissions and the response of large ice sheets in Greenland and Antarctica. The range of projections is wide, reflecting genuine uncertainty about both the emissions trajectory and the ice sheet response. The lower end of current projections, corresponding to significant reductions in emissions, places sea level rise by the end of this century at somewhere around 30 to 60 centimeters above current levels. The higher end, corresponding to continued high emissions and potential instability in the large ice sheets, reaches 1 meter or more by 2100, with the possibility of considerably larger rises in subsequent centuries for communities already living at or near sea level. The difference between these scenarios is not a matter of degree. It is a matter of whether the ground they live on remains livable within the lifetimes of people currently alive. The geography of global vulnerability to current sea level rise is a map of the places where human civilization has concentrated itself across the past several thousand years. River deltas and coastal plains were the sites of the earliest cities because they offered flat, fertile, well-watered ground, accessible to trade by water. The same geographic logic that made those places attractive for urban development in the ancient world makes them vulnerable to inundation now. Bangladesh, where a significant fraction of the national territory lies within a meter of sea level, and where tens of millions of people face risks from combinations of sea level rise, storm surge, and river flooding. The Mekong Delta in Vietnam, where the rice-producing heartland of a nation is sinking even as the sea rises around it. The Marshall Islands and Tuvalu, where entire nations face the prospect of their territory becoming uninhabitable within the lifetimes of children currently in school. Low-lying coastal cities across Europe, Asia, and the Americas, where infrastructure built for one sea level is already being stressed by another. These are not speculative futures. They are documented present realities in some cases, and near-term trajectories in others. The parallel with Doggerland is structural, not decorative. The people of Doggerland did not choose to build their lives in a landscape that was going to be inundated. They built their lives in the best available landscape, as all human communities do, and the processes that made it unavailable to them were operating at a scale that no individual or community could have detected or addressed. Their vulnerability was not a failure of judgment. It was a consequence of living in a dynamic world where the conditions that make a landscape habitable can change. The people currently living on the coastlines and deltas and low-lying islands most vulnerable to sea level rise are in a structurally similar position, with one crucial difference. The process threatening their worlds is not invisible or undocumented. It is measured, modeled, projected, and understood in considerable scientific detail. The knowledge of what is coming, which was entirely unavailable to the people of Doggerland, is available to the people of the contemporary world. What is done with that knowledge belongs to politics and policy and collective human decision-making rather than to science or archaeology. But the Doggerland story has something to contribute to how those decisions are framed. One of the things this story makes concrete, in a way that projections and models and sea level curves do not always manage, is the human reality of what is lost when a landscape is inundated. Not just the land itself, not just the infrastructure and the economic value of buildings and agriculture, the accumulated knowledge tied to specific places, the social bonds that a particular landscape sustains, the identity that comes from belonging to a specific geography across generations, the things that cannot simply be relocated to higher ground and reconstructed without something essential being left behind. The fishermen whose families have worked the same coastal waters for generations, whose knowledge of tides and currents and seasonal fish movements is inseparable from a specific geography that is changing, face a version of what the Doggerland communities faced. The farmers of low-lying deltas, whose knowledge of their land was accumulated across generations and embedded in a relationship with specific soil and specific water, face a version of what the Doggerland communities faced. The loss is not only economic, it is the kind of loss that a sea level curve cannot fully capture. It is the loss of a particular way of being in the world, tied to a particular place, that cannot simply be moved inland and replanted. And yet the Doggerland story is ultimately not a story about what was destroyed. It is a story about what survived. The people of Doggerland survived. Not all of them, and not without loss, and not in the same places, or the same forms that had existed before the inundation. But they survived. They adapted. They carried what they could. They built new relationships with new landscapes. They transmitted enough of their knowledge and social capacity through the following generations for the long chain of human continuity in northwestern Europe to remain unbroken. That survival was not guaranteed. It was not the inevitable outcome of a process moving toward a predetermined end. It was the product of choices made under pressure by specific people in specific circumstances. Choices whose details we cannot recover, but whose cumulative effect was to preserve enough of what mattered to allow recovery to begin. The people currently facing the prospect of losing their coastal landscapes to rising seas are not guaranteed survival either. Their outcomes will be determined, as the outcomes of the Doggerland communities were determined, by choices made under pressure, by whether the knowledge of what is coming is translated into action while there is still time, by whether the communities most vulnerable are supported rather than abandoned, by whether what can be carried from the landscapes being lost is identified and carried before the water arrives. The difference between the situation of the Doggerland communities and the situation of communities currently facing sea level rise is not only that the current process is better understood and better documented, it is that the current process is, to a significant degree, the product of choices made by human societies. Choices about energy systems and land use and economic organization that could, in principle, be made differently. The Doggerland communities had no agency over the orbital dynamics that drove the post-glacial warming and the sea level rise that took their world. The current generation has agency, imperfect and constrained and contested, but real, over the emissions trajectory that will determine how much sea level rise occurs and how fast. What is done with that agency is beyond the scope of anything the Doggerland story can determine. But the story can make concrete what is at stake, not in the abstract language of projections and scenarios, in the specific, human, irreplaceable terms of what is actually lost when the sea takes a landscape that people have built their lives around. The water is rising again. The question of what we do about that is ours to answer.